Here, let's take a look. So this is just to accumulate what we found here. Population standard deviation 2.8, and the sample size was 37. So why can I use z-scores? Why can I use the z-score chart? Yeah, because n is greater than 30. Chicken, lettuce, tomato. CLT says good. Normal enough. When I say enough, you know what I mean by that. Normal enough to use the chart. And we actually just did this one, right? I mean, hopefully some of you guys remember. Oh my God. Hopefully some of you guys can draw that better. It was 1.96, right? That's the one we just did. So if you did 0.025, you look it up, you get negative 1.96. The negative doesn't matter. People always mess themselves up because they throw a negative in it. It freaks them out. Plus or minus contains both, so you really just care about the number. Okay. So when you go to put that formula together, the mean, give or take, this many steps. I still have way too many people that are putting a number in the square root that's not a whole number. There's no way what goes to the square root cannot be a whole number because it's a number of things. N stands for number of. So don't put the mean in there. Don't put something else. It's N. It's the sample size. Is it cool with that? Yes. Stretching. What's the error that you get for this? Who is it?
0.9022.
Sweet. Just put it all out there like 0.90, whatever. And get to appreciate your calculator. Let me show you what the hell I mean by that. So watch how I do this. Look what I can do. 1.96 times 2.8 divided by square root of 37. Stow that shit in X. I think I showed you that before, right? The stow button kicks so much ass. Stow it. Then I can do 68.4 minus X and 68.4 plus X. And then I have to keep track of anything. I don't have to round too early. None of that stuff. It's a freaking calculator. Let it do its thing. So now I can round it when I give the answer. I don't want to round too early in a problem. So the interval would go from 67.5 up to 69.3. Well, there it is. Is that what you guys got? Something like that? If you gave me more decimal places, that's fine. At the end, you can make this have at least as many decimal places as that does. All right, so if you're not sure, just give me a few more. Not a big deal. Don't give me 7 decimal places. All right, let me stop there for a second. Is everybody with me up to that point? Does that sound like a pretty good interval? Do you have enough from what we talked about? Is that a decent interval? Why? Yeah, it's relatively small. The width of it is pretty small. The error that we got was less than an inch off, right? I like it. But if I need to know very specific data, maybe that's still too big of an error. That's going to be part B. How do I write this conclusion for this? We are 95% confident that what?
The interval 67.5 to 69.3.
Careful. 67.5.
69.3.
No? Inches? To 69.3 inches. Give me units. If you don't give me units, I'm going to be an asshole and say, centimeters? So give me the units. I love when I say centimeters, question mark. Somebody makes corrections, they put centimeters. I'm like, no. I'm not telling you the answer. I'm just being an asshole for a second. Give me units, so I don't have to be even more of an asshole. So we are 95% confident that the interval 67.5 inches to 69.3 inches does what?
Contains the true mean.
Contains the true mean what?
The height of men.
Height of men. And I didn't specify what area I was in, right? So it's just height of men. I must have taken a sample of all men from everywhere. All right, I like it. Yes, no, maybe so? I will take off points because it goes against the concept. If you say we're 95% confident that the true mean height of men is between 67.5 and 69.3 inches, that is wrong. That, and let me see, I don't know if anybody, you guys understand what I just said? You can't say we're 95% confident that the real mean falls into our interval because that's not what it does. It exists somewhere. What is it that kind of comes in second is my interval. So we are so confident that this interval we made catches the real mean. And I know that sounds like semantics, and I don't care because it's not. It's the idea of it. Maybe. Okay. Yes?
As a rule of thumb, when calculating the digits of precision in the interval, can we use the precision of the sample mean?
Yes.
Like if it's 68.4 inches is the mean, we have one digit of precision in our interval.
Yes, cool.
For quiz
I love
and
it.
testing purposes, we can use
Beautiful.
that as a rule.
Exactly.
Okay, cool.
Kick-ass. Did we hear that? And it's pretty much what I said, right? You can make the interval that you create, the numbers have to be at least as precise as the sample mean that was given. Okay, I like it. There's a whole other level that I'm definitely not getting into, especially not in 4 weeks, of something called significant digits. Has anybody ever heard of those? Anybody ever taken any chemistry? Sig Figs, Sig Digs? Yes, no, maybe so? Are you kind of happy I'm not doing that? To be real honest, how many of you guys have ever heard of significant figures or significant digits? I think in science they say Sig Figs, because in math we say Sig Digs just because we're different. We're like the Jets and the Sharks. When you're a Jet, no, West Side Story. Those are meant to convey very quickly, just by the number of digits I give, the certainty I have in something. So it's a very cool invention science came up with. But that's all I'm going to say about it. So I don't even bring that in. I could bring that in, but my God, that'd be at least a couple of classes just to discuss Sig Figs. Okay, so pretty cool that first one. So let's figure out where this equation for part B comes from. Which part of this equation was the error? This part is the error, right? So let me write it. Error equals this. So now watch. Here's the idea. We got, for a sample size of 37, how close did we get it? How good? What was our error for that? 0.9 something, right? 0.9 inches. So let's say that's not good enough. For the thing we're doing, we have to be within half an inch. So if a sample size of 37 led to an error of 0.9 inches, do I need a bigger or smaller sample to get my error to be 0.5 inches?
Bigger.
Does it make sense? Because we knew on day one. Why is a bigger sample better? Because then we are more, what? If it's a bigger sample, I'm more certain about what I find. You go take 3 people. Take their average age. How sure are you about the actual average age? You're not. No. Yeah, that's bullshit. Take 800 people. Okay. I feel pretty confident about what I see. Right? So if I want to make the error, now you see how the word within, because what's error mean? How far off I am. So if I want the error to be 0.5 instead, I'm trying to figure out what? The size of the sample, and what's the letter for that? Size of the sample. I know I'm saying size of the number of things in my sample. N. Sample size is always N. What's S? Sample standard deviation. I like it. So now watch this. This is the last thing we'll do before the break. Can you please, this equation sucks for what I need because I want to figure out what N is and I know what E is. Solve that for N. Solve that equation for N. said there would be very little algebra. I didn't say there would be none. Any math class after algebra, there's going to be algebra somewhere, I bet you. To some degree. So what sucks about trying to solve this for n? There's kind of two levels of suckiness. One level is n is where? Huh? In a denominator. And it's under a square root. Damn. So how do I make it not be in the denominator anymore? Like clear my fractions. Multiply by what? Yeah, multiply by square root of n. Because then these would cancel, right? One's on top, one's on the bottom. And on the other side, they show up now. So multiply both sides by rad n. And then 2 more steps and I'm done. Divide by e. Square both sides. So this is what I call a feasibility study. God, how weird are you, Jeff? So what does feasible mean? Do we know what feasible means? Is this feasible? Possible? How likely is it? How well can we do it? Is it something within our ability? Right? So if we do this formula for a situation and we get n to be 380,000 and we're one of us, that would mean I'd have to go take a sample of 380,000 whatevers. I'm like, hell no. Right? No. You got it with me? But if we get n equal to 102, okay, maybe I could do that. 102, sure. Right? So this is what I call a feasibility study. So in this case, we know that a sample size of 37 led to a 0.9. We're like, it's not good enough. How big of a sample do I now have to take to get that to within half an inch? Is that feasible? So let's see. Let's go back to the question. So this is going to be equal to what? What variable is this for? 0.5 goes in for what? E. And this is still at 95% confidence, so Z is still the same thing. Still the same problem, so sigma is still the same. Right? And to be honest, I don't know why I wrote it like this. I kind of like it better if it's like this. It's a little more direct. So if I put in there my Z score times my standard deviation was, where'd it go? 2.8 divided by 0.5 and square that. What do you guys get? So I just plug everything in. 1.96. We know sigma is 2.8. I want to be within 0.5 now. Get out of there, log. Get out of there. Barf. Okay. You guys get that? Is that all right? Why is that kind of bad as an answer? If somebody tells me to go take a sample of 120.5 people,
Can't do it.
I don't want to create Dexters. I don't want to. You're the last one. I just need half of you. Shut up. No, don't want that. If you say 120, you're wrong also. Nah. This is the minimum sample size required to get within half an inch. So if I make it less than this, I'm not within half an inch anymore. So you always round this sucker up no matter what. Unless it comes out to be a whole number. Even then you want to round up, to be honest. So this will be, so I get 120.47 blah, 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 but I round it up to 121. So that's how many total dudes I need. And how many dudes did I already measure? God, that sounded weird. Oh, wow. 37. So I could ask you, like, how many more men would you need to sample? So you just would subtract 37. You guys see what I'm saying? So it's kind of like sentence already served. So you can subtract that. Hopefully nobody's really intimately aware of that. What I just thought.
That'll bring your final error to something like 0.497.
Yes. My estimated error.
Under
I
your
like
limit.
it. Now look, the biggest mistake people make is they just forget, they just say, I'm not going to use that. I'm going to put in the 0.9022 because that's the error right now. If you put 0.9022 in here, what are you going to get for n? Don't even do it. Just if you put an error of 0.9022, you will have to get 37. We already knew that shit. I already knew that 37 leads to 0.9 error. Don't tell me that again, right? Okay. Let's take a break. Come back, I don't know, 10 till. I'll give you a smaller break today. Ha. Too bad. Come back till at 5 till. Go ahead. I'll give you more time. Come back at 5 till. Oh,